Hi, I am Harish. This is Lab 1 of Python Deep Learning course. Uh, as you are seeing, this is the first question in the lab. So you are given a list of tuples. So these are tuples, which has, as you can see, there are there are two tuples with the same key like John. So the requirement is that you have to make a dictionary. Uh, you have to append all the values which have the same key. So just take a list like this and initialize a dictionary of a with the help of default dictionary, initialize it with the initialize it with the list. Why? Because you have to put the values. There will be so many values, so it has to be stored in a list. So you have just iterate with every key and value in a list and append the value which has the same key. So if you see here, the key will be John and it will be stored physics and 80. When it goes here again, already in John you have a value. So we are creating a dictionary with a list. So the second value will be appended, and after that you have to sort the dictionary. So you can either sort with a value or a key. So I'm sorting with the help of key. So I'm giving this 0 and I'm just printing it. Let me run this. Yeah, as you can see, it got sorted. First one is Daniel, second one is John, and third one is Mark. And let's go to the second question. You have to find the longest substring without any repetitions. So without any repeated characters present in the substring. So it just take a empty string and empty dictionary. So you have to just iterate with every letter. And if you see here, when you are iterating every letter, within iteration you have to append every word to a string, and if you find the next word which comes when you are iterating, uh, I mean when you are iterating, if the coming word is present in the substring, then just stop it and store into a list, which I am doing here. So here which I am storing. Here I am storing in a dictionary. Why? Because I want to store the key as the substring and the value as the length of the substring. So after getting all the dictionaries, I am seeing for the max length value. Then I am getting the max length value, and I am iterating through whole through the dictionary. If the value matches with the max value, then I am storing into a list and I am just printing it. Let's run and see it. So you have given string is pwwkew and your longest substring without repeating characters are wke3 and key w3. This is the second test case. And the third one is create a library management system which have classes, which is made up of class, functions, and etc. It has some requirements like one should have private number, one class should use a super, and all instances and the family members should be used. So here I have created three classes. One is library, one is loan books and student. Loan books and student are child classes which are inherited from library. Library is a parent class. So in library, I'm using book list as a static list because whenever I'm giving, whenever I'm calling this class with, I'm giving the arguments as a books list of books, which it should remember the previous state also. That's why I'm giving the static value. So here get book list means it will just return the book list. Display means it will print the book. Show you the book list. Checkout means it will check out the book and remove from the book list. Check-in means it takes the book and add into the book list. Loan books means why I created because one library can can lend the books from another library. So it is just lending the loan. in loan books, it just have to lend the books from another library. So just by calling super method, it will go to the parent class, and as it is, it will function. I mean, the functionality will be the same, storing all the books. And in the student library, I mean, sorry, student class, I'm storing the student info, and a student can request a book. This is request. When he requests a book, you have to check it out. So I'm using the checkout method, which is used in the parent class. And return book means when he returns the book, it has to be updated in the library. So I'm using the method check-in book method from the parent class. Okay, so as you can see here, these are the different test cases. For the first, I am keeping the books Harry Potter, Secret 7, and these four books. So it will be stored in library. So now I am giving the details of the student. Now just I want to display the books. It will show the books, and he is requesting a book, A Prisoner of Birth. So when he requests the book, it goes to the student account, and it will be removed from the library book list. Then again, I am displaying books, and the student book list differentiation should be there. And again, I am returning a book, and after returning a book, I am displaying the books. So student, and I am storing the student info, so I am displaying the student info. So here I am lending a book, Heads You Win. So it will be stored in the library. So again, for it, I am displaying the books, and I am using a private member, that is phone number, which has to be used like this with the help of class name. If you are, I mean, class name. I mean, this is the object created, and this is the class name, and after that you have to put two underscores and the member. Whereas if you directly access with the object and just giving the member, it won't. It's the wrong way to write the syntax. You will get an error. So just let's run the program, and you will get to know. As you can see here, the books are available are these four books. So again, student asked, so book is issued successfully. So the books are only three. In student book card, this is the one. Now book is written successfully when the student returns. So when you see there are four books, the student info is this: name, phone number, student, department ID, etc. Now, as I told, loan books are done. So if you can see, another one is added. So I'm accessing the private member of the class. It will show. So this is the third question, and coming to the sixth question, which is clustering. So I took a dataset called college dataset, which has 18 features, 19 features, where one of the feature is strings. I mean that the college name. So I'm ignoring that. So other than that, I am considering all the data. So I took a target variable as private. Private means that whether it tells that I mean the college is private or not. So for that, for the given data, I want to do the clustering. So for the first time, I am checking the value counts, and after that, I am taking the data into the data frame here. As you can see, I am doing the value counts. Here I'm checking is the data frame has null values or not. If it is having null values, I have to replace the null values with the mean value. As here in the data frame there are no null values, so I'm not replacing anything. So after that, I'm dividing the data set of dependent variable and the independent variable. Now with the help of elbow method, this is the code. I'm I'm able to know what are the optimal number of clusters. So when I execute it, I will be getting 2 as the optimal number of clusters. So with the 2, I am initializing the k-means. I feed the data, and I'm predicting the values. With the predicted values and the true values, I'm calculating the score. So after that, I just wanted to do the standardization, but with the help of standardization, my accuracy is not improving. So without standardization, I'm doing PCA. I just wanted to check whether the accuracy level increases or not with the help of dimension static detection. So I'm giving only two dimensions. I'm fitting the train data. I mean X data. I'm sorry, uh, the features data. So after getting that, I will be getting a data frame. I will be getting the data, and just you can print it. Now I am again doing the k-means with the help of, with the number of clusters too. Just the same procedure which I have done above. I am fitting it and I am predicting the values of the test variable. Test. Test set. From there, I am calculating the silhouette score, and I am just plotting the clusters with the help of scatter plot. Now let me run, and that will be easy to understand. So it will take some time to run. So as you can see here, there are two value counts, S and no. There are no null counts, and I'm displaying the elbow graph which has uh, and bend here. So I'm considering 2 as the number of clusters. Let me close this one, and as you can see, the silhouette score is for the normal k-means is 55%, and these are the two clusters. So let me close this too, and so these are the values after doing PCA. And if you see the score after performing PCA is 59, 4% is, the score is being increased, and this is the plot which has two clusters, like because it will be deciding yes or no. That's why uh, there are only two clusters are optimal way. So this is the requirement for the clustering. uh, uh, these are the 4 questions done, and the other two will be in another video. Thank you.
Let's see the fourth question. So the fourth question over here is to create a multiple regression by choosing some of our data set, either an online or the used one, and do an EDA and check whether the R square and RMSE has increased before and after, before to after. So yeah, let's see the demo part of this. So over here I have imported the necessary libraries, so which I have used over here: NumPy, Panda, Cburn, and Cyburn, SciPy Stats, and Matplotlib for visualization, Cburn for visualization, NumPy for computing, and Pandas to read it in the tabular format and to perform operations to that, and other scikit-learn libraries which I had to use. So this is the data frame called graduate, and the CSV is admission product, and this is the first few records, and data types. These are the data types for each of the column. So I saw that serial number, there is no significant use that a model can learn, so I have removed it. And also this is the shape. We have 400 rows and 8 columns, and I renamed the columns so that it is useful for manipulating the data frame or doing some operations on it. So this is after that, and I have verified that there is no null columns. So there is null column, so this is what it is, and I have just to cross check, I have even dropped it. And I have did standardize the graduate and TOEFL by subtracting with the mean and dividing with the standard deviation. By doing this, we are saying to the model that these two particular columns are equally important as the other columns. So we standardize those. This is how it is, and this is after the standardization. And I have seen the data distribution of GRE. So one of the column is GRE over. This is the data distribution of that column, and this is the data distribution to check what's the range in which particular range has more data in that frequency. So this is for TOEFL and this is for CGPA. So I did a correlation for all the columns, and over here are most of them everything are numerical, quantitative, so all of them are numeric. This is how it is. A pair plot, I've used a pair plot in C1 where it shows the similar one which we saw in this number format. It is visualized in this graphical way, and I have verified the correlation for each of the attribute. The first one which I have taken over here is GRE, and the target variable is over here as chance. So GRE versus chance. We can see here, we can plot a regression plot by seeing this, and the Pearson correlation is also 0. Less than 0.05, which says that is a significant value. And this is the residual plot, so which means that the errors should be equal to the mean. So this is the mean value. The values which are above 0 and below 0, if you sum up it will be 0. The same thing I did for TOEFL with the chance, and we see there is a straight line, and the Pearson coefficient is also less than 0.05, and this is the residual plot. The same thing goes with the CGPA. And SOP, while going with the SOP, I see that it is not that consistent, whereas comparing it to the first three. University rating is also the same, the research is also the same. The Pearson coefficient is not that significant. So starting, I would perform multiple regression for all the columns except the target variable, which is chance over here. So X has all the columns and Y has only the dependent column. So it has all the independent and dependent column. The shape is 407. So if you see, before it is 8, now it is 7. So shape is the chance. So this is what it is. So here where I initialize the linear regression and I fit the training data, and I have predicted on the unseen data, and I see that MSC is around 65% and R square is also 81%. R square is 81%. So here I have just taken the first four most significant correlated variables with the chance, and we see that CGP and GRE, TOEFL and university rating as the high among among the every other attribute. So X is being those three variables, and Y is that dependent variable, and this is the shape, and this is the data shape we have at the after doing the correct columns, selecting the correct columns. And same thing, I refitted the linear regression, initialized the linear regression, fitted the training data, and these are the coefficients intercept just to see. I added it and I predicted on the unseen data. The MS is 65% and R square is 81%. There is not much change compared to before and after, but by the CDA process I identified the most correlated things by using regression plots and residual plots. With this, there is a little improvement in the R square, whereas MSC is almost similar. There's the points and difference. Earlier it is 64, now it is 65.5. Yeah, this is all of the fourth question. Thank you. Let's see the fifth question. So the fifth question over here is to pick any data set which includes numerical and non-numerical variable, perform EDA and apply 3 classification algorithms, which is naive Bayes, SVM and KNN. Let's see the demo part of this fifth. So I have imported the necessary libraries over here. So these are the necessary libraries which I felt, and this is what I imported. And the data which I have taken here is the IBM data set. So it consists of whether a particular customer churns or not. So by end of the day, we should be able to predict whether a particular customer will be churned or not, given on the basis of the categories. So this is where I'm reading as a pandas data frame, and I have displayed it. These are the 5 records On the top and the shape is we have around 7,000 records and 21 columns. These are the types of each of the column, and I verified is there any null. So it is there is no null, and these are the object related columns over here. And I have seen that there is empty data present in the total charges column. So this is what it is, and I see there were around 11 records, and it came around 0.15%, which is very less than. So we can simply go and drop those records, or sometimes if it has good impact, we would be replacing it with a mean value. So here I followed deleting those records as it is very less percentage. So I replaced it with an npnan, and then I dropped those records, and I've converted them to float and made those columns as float. And these are the unique values present in each of the data related columns. So gender, senior citizen, so these are the data related, category related, qualitative related attributes, and this is its respect to data. So I saw that there is no use of the customer ID as there is no impact for the machine to learn this particular column. So I went ahead and dropped this column. So this is the existing visualization. As I said, it deals about the churn and non-churn, and it is around 26% of the data is churned, whereas 70% the data which consists 70% is not churned. So this is the correlation on the numerical data. I see that the monthly charges, total charges, and tenure are the correlation, but among them is with monthly charges is highly correlated, monthly charges and total charges. So we can go ahead and drop the total charges as there is two columns are highly related, which doesn't make any sense for the model to learn these two columns. As it learns one column, it would be enough for the model to learn of that particular column, as they both are highly correlated to each other. And this is the just correlation across all the columns. And churn is the major factor which we would be looking at. And as I said, these particular columns are category columns, whereas the models would be expecting the data in the quantitative manner. So here what I did was I mapped it with S as 1 and the no as 0, as this column consists of S and no. So all this gender, partner, dependent is phone service and paperless billing. For all these columns, I've converted respectively to 0 and 1s. So it is same using the pandas get dummies. So I saw that multiple no phone services is always no when there is multiple lines no is selected. So I have removed this column as it doesn't make any sense, as we are capturing the same data under the multiple lines attribute as no. So it is always true when it is no. So for all these columns I have dropped it, as it's capturing in its respective column called, if you take this device protection no internet services, if there is no internet service, if the user has internet service no, it's always device protection no is always true. So it doesn't make any impact as this particular record is captured with this internet service. So after removing all these columns, it came to around 33. So these are the distinct columns which I had now. All, if you see, all zeros are ones, whereas before is yes and no. So here as well I have normalized the data. Same with minimizing the min and dividing the max minus min, to make sure that each column has given equal importance and it is range between 0 to 1. So here I have used RFE method. So what is the RFE method? Is a recursive feature elimination method, which is similar to the backward selection. It identifies which columns are most important by eliminating one by one, by making a choice, selecting choice of 3 2 1 3 2 1. By this, we'll know the most most effective factors. So from this, I have taken the top 25 columns, and over here is the last column is the target and the target column. So the test size over here is 70/30. So after selecting the data, this is how, after splitting the data, so churn is around 26% and 73%. So let's perform KNN. So basically, we have used in EDA to identify the most efficient columns and eliminated the inefficient, which are not that impactful, like phone services, no protection devices, no services, and total charges, and remove the and replace the empty data. So let's see the model phase. The first phase is KNN. So I've seen that when K is above from 15, it has good a score. The on the y-axis is the score and the x-axis are the ranges. So here I have taken as k as 15 and I have initialized with n neighbors as 15 and I fitted it and predicted with an unseen data and I got an KNN accuracy of 78%. So as it's a classification problem at hand, so I have used confusion matrix to verify the accuracy. So the same thing, I got 78% and precision recall, and this is the more detailed level. The same thing I did with the SVM. I've initialized, so I got this hyperparameters using a grid search over here. After performing this, I got this grid search and here are the values. So it's the same thing, I fitted the values and I predicted it, and this is the confusion matrix which I got. It has 80%, and this is all detail level, precision recall, F1 score and support. And then AWS is also the same. What is it? I have initialized the model and fitted the training and test data and predicted the unseen data, and the accuracy of this model is 73%. The same thing I did using the confusion matrix to get in more detail. So this is what it is, and 73% is the navy base. Out of all, I see that SVM has much more has given me the good accuracy, which is 80%, whereas rest all others are around 73 and 74%. Yeah, this is all about the fifth question. Thanks.